It feels really good to look at Mars again after 37 years since the last time I saw it through this telescope. And that was the first time I'd ever seen it really glowing like a three-dimensional object there in space. And I was fortunate enough to be able to pursue that image through spacecraft taking pictures up close. And I stayed here in the ground and helped design spacecraft and looked at the pictures coming back and got to know Mars and discovered what an extraordinarily challenging place it is and why I think humans are going to be pursuing Mars until they really get there and find out whether it's a habitable planet or not. It's a wonderful thing to study.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1. We have ignition, and we have liftoff as America begins its journey back to the red planet.
We're good symmetrical burn on all 6 solids.
It's about to get very busy on Mars. Pathfinder, which arrived there today, is just the first of a dozen missions that will explore the red planet over the next decade.
We have burnout on all 6 solids and ignition of all 3 airless solids.
These missions have been given unexpected importance by the meteorite ALH 84001, which is believed to come from Mars. Deep within this rock, NASA scientists have discovered strange structures which they interpret as evidence of primitive extraterrestrial life. Pathfinder and the spacecraft that follow it will find out whether NASA is right, whether there really is life on Mars.
July 4, 2100 hours, and we are waiting for the moment when the spacecraft will begin its first transmit session, which is just about now. And this is where I'll be at about that time on the 4th of July, looking at these screens, watching our telemetry data come down for the first time on the surface of Mars.
Pathfinder Mission Control is at the Jet Propulsion Laboratory in California. Since the dawn of the space age, JPL has been at the heart of our journey to the planets. This is the story of the race between America and the Soviets to explore Mars, and it's a story of both triumph and heroic failure. Bruce Murray has participated in this adventure from the very beginning when he took part in the first American missions to the planets.
I think that everybody who was working on the first flights to Venus and Mars believed it was a great adventure. They also recognized it was a very, very difficult thing to do. This was a place for people, in terms of the engineers, who had honed their skills on immediately post-war development of rockets that had blown up and they'd succeeded. They had confidence in themselves, they had confidence in what they were doing, but they knew about the risk.
Caltech's Jet Propulsion Laboratory, the oldest continuous rocket and missile activity in the Western world, was the first in the field with a guided ballistic missile. From the first firings of missiles in the area that was to become the Edwards Air Force Base range, to the first firings at Cape Canaveral, the Jet Propulsion Laboratory's successes in the field of ballistic missiles led the way for other, even more ambitious projects.
6, 5, 4, 3, 2, 1, 0.
Jack James joined JPL in 1950 before the existence of NASA, when it was funded by the military.
The Army was extremely tolerant of us. They thought we were a bunch of whiz kids out here on the coast and we could do no wrong, and they actually looked the other way when we had all sorts of pranks going, like making a film. Well, it was a different world when we went to work for NASA.
This is Radio Moscow.
But NASA was not first into space.
The first artificial Earth satellite was today successfully launched in the USSR. As a result of intensive work by...
In 1957, America was humiliated when the Soviet Union launched Sputnik. And the Soviet chief designer soon had the planets in his sights.
I think Sergei Korolev was very smart to understand that something related to deep space flights would be even more impressive. As early as 1959, less than 2 years after first Sputnik, Sputnik 1, Korolev launched a spacecraft which flew at certain distance from Mars. It was still too far from Mars, but it was enough for Pravda newspaper and for TASS agency to declare the first interplanetary flight.
Few pioneers from those early days are still working in the space program. Boris Chertok has survived. Now in his 80s, he still arrives punctually every morning at the Energia space facility.
И надо сказать, что холодная война, как это не парадоксально звучит, может быть, очень способствовала прогрессу не только боевой ракетной техники, но и достижениям космонавтики, не имеющей прямого отношения.
In 1962, the Cold War turned hot, just as Boris Chertok was preparing to launch a probe to Mars.
It shall be the policy of this nation to regard any nuclear missile launched from Cuba against any nation in the Western Hemisphere as an attack by the Soviet Union on the United States, requiring a full retaliatory response upon the Soviet Union.
At the height of the Cuban Missile Crisis, Chertok was told to remove his Mars probe from the launch pad and replace it with an H-bomb.
Мне удалось уговорить его затянуть снятие ракеты марсианской всего на несколько часов. Но как раз эти часы пришлись на тот период, когда два, надо сказать, довольно разумных руководителя государств, Хрущев и Кеннеди, успели договориться между собой, и пик кризиса прошел. Мир мог вздохнуть спокойно.
A few days later, Mars 1 was launched. Although its radio failed halfway to the planet, it was trumpeted as a success in the Soviet press. Meanwhile, the Americans hoped to seize the lead with their own spacecraft, Mariner.
This, the Mars Mariner unmanned spacecraft, is designed to fly close to the planet Mars, to take meaningful scientific measurements, and to relay to Earth its findings.
In these early days, a real problem was component reliability. JPL was experiencing embarrassing failures with its Ranger spacecraft, which were attempting to photograph the moon.
Jim Burke, who was the project manager of the ill-fated Ranger, said to me, "Jack, just realize this, you're a transistor away from being a hero or a bum."
Mariner 3, the product of 2 years' careful assembly and testing, blasted off perfectly for Mars in November 1964. It was America's first attempt to reach the red planet.
Yeah, I was in JPL's control center, and I was probably one of the very first people to realize that something had gone wrong. We were getting the first tracking data coming in, and it was clear that something was wrong with the spacecraft. And we finally put all these pieces together and realized that the spacecraft had never come out from underneath its cocoon, so to speak.
The white nose fairing was designed to protect Mariner 3 during launch. Instead, it became a funeral shroud, trapping the spacecraft folded up inside.
In 3 weeks, the JPL engineering team designed a new shroud, built it, tested it, and launched Mariner 4, and it worked. That was a kind of remarkable ability to recover from adversity that I think was the reason the U.S. planetary program was so successful for those first 2 or 3 decades.
This time there was no mistake. The new shroud separated perfectly, the solar panels deployed to power the spacecraft, and Mariner 4 headed off for Mars. To discover what? These were the clearest views of Mars available in 1964. They showed a polar cap and dark markings on the surface that altered with the seasons. Vegetation, perhaps? Early in the century, the American astronomer Percival Lowell had claimed to see canals crisscrossing the surface. He believed they were the work of a dying civilization struggling to irrigate the planet.
Oh, I think we thought there might be life there. I don't think any of us thought that there were people that lived on Mars, but I think most of the science community, I thought, believed that it would not be unlikely that there would be life on the surface of Mars.
As Mariner 4 swept past Mars, its black and white television camera snapped 22 close-up pictures of the planet. These images, the first ever digital television pictures, were stored on a tape recorder. Then they had to be radioed back to Earth.
Would you believe that our bit rates in those days were quite low? I think it was 8.3 bits per second, a little faster than a pretty good telegrapher can do dots and dashes.
So the 8 bits per second came from Mars, from the spacecraft, to the big antenna out in the Goldstone antenna range. And they were actually teletyped back. And they came in as little strips of zeros and ones. Incredible.
Yuri van der Wood is keeper of JPL's Planetary Image Archive.
Just outside the office you will see that here are these little strips, and you can see the groups of numbers that indicate the strength of the return signal in light and dark. As fast as we could staple these little strips on and we could color them in, we started to see a picture.
Mariner's first picture shows the lower edge of Mars with a planet in the top of the frame and the black of space below.
To the old-timers particularly, it is a thing of tremendous value. I would almost say I burn candles here at night, you know.
All the frames as we got them had about as much texture as seemingly to the eye as this, when you just made a Polaroid off the screen. But since this were digital, they were computer numbers, we could subtract, and that's what we did. And the amazing thing for us was there were huge craters. One was 200 miles across, like the moon. And so the fact that they were standing right there on Mars today means that Mars had not had oceans, hadn't had weathering and erosion for 3 billion years. And surely it would not have had a life of the type we know anyway, if it had been dry for this whole time.
JPL's engineers were impatient to be shown what the scientists had discovered.
Dan Snyderman, my spacecraft system manager, were invited into this room, and here were these little Polaroid shots all around. And we looked up and there were craters, craters, craters. And Dan jokingly said to me, "Jack, you and I have a 20-minute jump on the rest of the lab to get another job."
Despite finding only craters, Mariner 4 was acclaimed a technological triumph. Jack James was invited to Washington to present frame number 11 to President Johnson. LBJ needed some good news even from Mars, weighed down as he was by the growing conflict in Vietnam.
I do not find it easy to send the flower of our youth, our finest young men, into battle. But I know them all, every one. I have seen them in 1,000 streets, working and building and filled with hope and life.
Roger, Houston, Apollo 10, you can tell the world that we have arrived.
As the 60s drew to a close, Apollo raced to fulfill Kennedy's promise to land a man on the moon before the decade was out.
How's the view, 10?
The Soviets needed a matching space spectacular, and Mars was the target. 2 giant robot spacecraft were made ready, each more than 10 times heavier than Mariner 4.
In 1969, we even attempted a very sophisticated project. First to get to the orbit around Mars and then to land on surface. Unfortunately, what happened, the launcher blew at the launch moment.
Days before this disaster, NASA had successfully launched their own spacecraft bound for Mars, Mariners 6 and 7. For the Russians, it must have been a bitter pill to swallow.
I had this image of a bald-headed Russian general sitting there in the tracking center, just beside himself that we were succeeded. I'm not proud of those feelings now, but that's exactly how I felt at the time.
I see the picture developing here. So here is our first view of Mars since Mariner 4.
Yes, on.
By spacecraft. By spacecraft.
The bright feature that you were talking about, Bob, is still just right at the little edge on. It's rather...
That's rather clearly a cloud.
It's an extraordinary feeling, although one is often very fatigued at the time. But the sense that one is seeing a surface, a real surface, not a movie, that no one has ever seen before, is a very powerful one.
That's beautiful. That's beautiful. Look at those little craters. This is a narrow-angle camera view. And I think this fully confirms that the Martian surface resembles that of the moon very, very much.
How is the quality of the TV? Oh, it's beautiful, Mike. It really is.
Mariner 6's encounter with Mars took place a few days after Armstrong and Aldrin landed on the moon.
You got the flag up now, and you can see the stars and stripes on the lunar surface.
Mariner 7 was closing on Mars a few days behind, but then disaster struck.
So far of anything happening? Before the...
Without warning, Mariner 7 fell silent. John Cassani struggled to contact the stricken spacecraft and invented an explanation that has become a legend at JPL.
The Great Galactic Ghoul is the monster that lives in the vicinity of Mars and gobbles up spacecraft. Surely you knew that. The ghoul paroles the perimeter of Mars and has chomped on Russian spacecraft, and now here's the first bite out of a U.S. spacecraft.
The Great Galactic Ghoul had apparently attacked one of Mariner 7's batteries. The resulting explosion caused the spacecraft to tumble until JPL managed to transmit a stabilizing command. Mariner 7 flew beneath the Martian South Pole and found that it was colder than expected, made of dry ice, not frozen water. To find out if life might survive there, it would be necessary to land. The Russians decided to attempt it. Designing an ingenious vehicle that would hurtle into the atmosphere and yet land softly on Mars. In the late 1960s, a series of strange tests took place in remote corners of the Soviet Union. In the spring of 1971, 2 new Soviet missions thundered off to Mars. Mars 2 and Mars 3 would orbit the planet and attempt a landing on the surface. But as the probes neared their target, the Great Galactic Ghoul threw in a nasty surprise. A huge dust storm blew up to envelop Mars. The Soviets had no choice but to press on.
Probably it's the most exciting moments of the life when you receive signal from the planet. So when it happens, it is the only opportunity. If you will miss it, you will miss it.
Viktor Kochonovich was at mission control for the landing of Mars 3.
It was exciting when you get this data. It was when it started transmitted, and a great disappointment when it stopped transmitting in 40 seconds and you could not do anything else.
В каком году? Ах, вы знаете, не знаете.
Despite its fleeting survival on the surface, a replica of Mars 3 is prominently displayed in the museum of the factory that built it.
Достигла околомарсианского всего пространства и впервые в мире осуществила посадку на поверхность Марса.
The Russians are proud of their accomplishment in landing the first human artifact on another planet.
I was hoping that during the last few days, as we got closer to Mars and the dust cleared, that we see a lot of Martians standing there with huge signs saying Bradbury was right.
America too launched a spacecraft which arrived at Mars during the dust storm of 1971. As Mariner 9 neared the planet, JPL organised a public soiree for scientists and science fiction writers to explore the theme of Mars.
Every time I get a group of people together and have them trapped in a hall like this, I bring a poem, see? And you can't escape me. Luckily, it's a short poem, but it sums up some of my feelings on why I love space travel, why I write science fiction, why I'm intrigued with what's going on this weekend on Mars. And if you'll permit, I'll read it to you. It's very, very short. Oh, Thomas, will a race one day stand really tall across the void, across the universe and all, and measured out with rocket fire, at last put Adam's finger forth, as on the Sistine ceiling, and God's hand come down the other way to measure man and find him good and gift him with forever's day? I work for that. Short man, large dream. I send my rockets forth between my ears, hoping an inch of good is worth a pound of years. Aching to hear a voice cry back along the universal mall, we've reached Alpha Centauri. We're tall. Oh, God, we're tall.
When we finally got to Mars and went into orbit, the planet was still completely enveloped in a dust storm. But because we had a memory on board the spacecraft, we could revise the mission plan. We were able to kind of sit in orbit and wait for about 2 or 3 months and watch the dust slowly settle out of the atmosphere, and then we started our mapping mission.
Mariner 9 overturned everyone's thinking about Mars.
And here is something which no one guessed would exist on Mars at all. This is one of hundreds of little channels. This is actually not so little. This is a few hundred miles long. Channels which look for all the world as if they've been cut by running water.
The thousands of pictures from Mariner 9 were meticulously pieced together to create a detailed photographic map of the planet. Here were old riverbeds, huge volcanoes and giant rift valleys. Mars once again looked like it might harbour life. The Soviet Union was determined to capture the prize of this discovery. In 1973, they allocated 4 huge Proton launchers to the task.
You must remember that by that time, Soviets already lost competition to land men on Moon. And 4 Protons is a huge chunk of money. It was an extraordinary effort to get, in a certain way, revenge, a chance to rehabilitate. And it was the last serious attempt to beat Americans in our Mars exploration. Few months prior to the launch, we discovered that the whole series of specific microchips, which were used widely in every device on board of this Mars spacecraft, had a kind of virus. It was not a biological virus, it was a kind of technological defect which led to corrosion over a period of few months. I was present at very serious meetings, to launch or not to launch. Industry had nothing to substitute this particular microchip. So it was a Russian roulette, Russian space roulette. 4 spacecrafts, only 2 survived.
Even the 2 surviving spacecraft were crippled. The pictures they returned were no better than those from the Americans, and the remaining Soviet lander failed before it reached the surface.
They wanted to get there very, very badly, and I'm sure they were deeply disappointed when the U.S. got to the storied planet, the one that life might be at, before they did.
The chute has been deployed.
Format 3 is in sync. Format 3 is sync. Leg deploy. Out.
So we're coming down, straight down.
ACS confirms coordinate transformation change. ACS is green, 1.5 degrees per second max, 0.2 Gs. 8 feet per second. Touchdown, we have touchdown. Extra zone.
We have touchdown.
Neighborhood zone.
In 1976, an American mission comprising 2 orbiters and 2 landers arrived at Mars. This was Viking.
There's the first piece of information.
Yep, that's it. That's it. Oh.
Oh. More, a few rocks.
Oh.
That's beautiful.
Oh. Oh. This is just incredible to see that the Mars, is really there.
Dave Pieri was one of the lander commanders. He was part of the team that programmed Viking's cameras to photograph the desert landscape around each of the landing sites.
Here you're looking out over the lander. We see, first thing we notice is an impact crater on the horizon here, probably several hundred meters away, and a dune field, sand dunes out on the horizon, and several large boulders that are perhaps several meters in diameter, any one of which would have killed the lander if we had landed on them. It would have been very dangerous for us. This boulder actually was originally called Big Bertha, but for reasons of political correctness perhaps at the time, the emerging women's movement, deference to that, we decided to call it Big Joe.
A week after landing, the Viking 1 robot arm scooped up a sample of Martian soil to look for life. For Gil Levine, who designed one of the 3 life detection experiments, it was a turning point that has left him at odds with many of his Viking colleagues.
In the 20 years since we got our Viking results, I have never let a day go by when I haven't thought about those results.
Officially, Viking did not detect life on Mars. But that's not how Gil Levine recalls the outcome of his experiment 20 years ago.
It was about 7:30 at night at JPL. Pat Stratt and I were huddled over the computer which was spitting out the data, and we looked and we couldn't believe it. The first clip of data represented the first 8 hours of the experiment, and there was a startling positive response.
The experiment involved analyzing some Martian soil in a miniaturized onboard laboratory. The sample was moistened with water containing radioactive nutrients. Any radioactive gas given off might indicate life. If so, then heating the soil sample should kill off the effect.
To confirm whether or not the response initially obtained was biological in nature, a second sample of the soil was heated to 160 degrees centigrade for 3 hours, cooled, and the experiment was repeated. We held our breath and waited anxiously for the same data to come down, and lo and behold, the response was nil. There was no response after heating of that sample, completing all the evidence that everyone had agreed to prior to the mission that would confirm the presence of life.
Other Viking experiments seem to rule life out. In particular, Viking could detect no organic compounds in the soil. Most scientists believe that Gil Levine's results must be due to odd reactive chemicals in the Martian soil, but to this day, no one has managed to replicate Viking's results on Earth. It's one of the mysteries the new missions may soon help to solve. As for the 2 Viking landers, they continued to send back pictures for 5 years, far exceeding their manufacturer's 90-day warranty. It was a remarkable achievement by the 20,000 people who helped send them to Mars.
If I were the first person to walk up to one of the Viking landers many years after it had actually landed on the surface of Mars, I would just be overwhelmed with the magnitude of the effort that it took to get both myself and the Viking landers to that point.
Pat Rawlings is a space artist. He has been commissioned by JPL to paint an accurate portrait of Pathfinder with its Sojourner rover as they will shortly look at the landing site on Mars.
I've thought through what the Pathfinder would look like when it's in its final stages of landing. You know, if you're standing on Mars and you're looking up, off in the distance you see a little white speck kind of against the ruddy, darkened sky. And if it's coming in directly above you, you see 3 very brilliant rockets firing. And at the same exact time, the lander with its airbags cut loose and drops to the surface, kicking up large gouts of red dust. Since this picture is more of a portrait of the lander instead of a conceptual painting of a vehicle, I had a number of visual references from the Jet Propulsion Laboratory, pictures that they had shot just before they closed out the vehicle before launch.
After a gap of 2 decades, NASA is going back to Mars. Flying 2 months behind Pathfinder is Mars Global Surveyor. It will map the entire planet in fine detail. It's controlled not by JPL, but by Lockheed Martin from Denver, Colorado. It heralds a new generation of smaller, cheaper, and smarter spacecraft. In this new era, some things stay the same. Norm Haynes is still involved in Mars missions. In fact, he and Donna Shirley are in charge of them.
It's a very exciting time to be working on Mars. Mars has sort of had a rebirth again. We're doing missions regularly, and we're doing missions that require a lot of new technology.
The first new technology, which is being put to test this evening, is the mechanism for landing. Pathfinder is using a complicated mixture of heat shield, parachute, rockets and airbags to get safely to the ground. The Russians must be feeling a sense of déjà vu.
Here we have the lander in its landed configuration with the rover sitting on one of its pedals. And what happens is that Pathfinder is going to fly from the Earth to Mars, enter the atmosphere. When we get close to the ground, we have a radar altimeter that senses that, and then some rockets on the back shelf fire. And then before we hit the surface, it gets very exciting. Some great big airbags, twice as tall as this room, pop out, surrounding the lander and protecting it. We cut the bridle, the airbags hit with the lander inside and bounce as high as a 5-story building and roll and tumble across the Martian landscape. When they finally stop bouncing, then we deflate the airbags, and they're tucked in under the pedals here, as you can see, so that they won't flop over the solar panels. And then when it's all deflated, we open the pedals of the lander, which is shaped like a pyramid, open like a flower, and here's the lander in this configuration.
This is exactly where Pathfinder should be right now. The day, or sol as Martians call it, has just dawned. At JPL, it's lunchtime.
About 2 o'clock in the afternoon, it will have stopped bouncing and rolling and tumbling. The sun will have come up. the camera will have located the sun on the horizon, and that tells the high-gain antenna which way to point. And all of the data that we collected during this wild ride in will be sent back to Earth over this high-gain antenna.
It'll arrive at Pathfinder mission operations.
All of us here that have been working in operations have been very close to the spacecraft all along. I've been involved in this project since near its inception, touching the spacecraft with my bare hands, going over every issue, every design issue, and it's hard not to feel that it's a living thing that's yours. And so in that sense, it really is an extension of us. The spacecraft will be our eyes and ears on the surface of Mars.
Oh, yes. Our hearts and souls and a little blood, too.
You bet. Yeah, this was an incredible team effort, and everybody, a lot of people have been working on this job for over 3 years, and it's been, for many people, the best job of their careers.
Oh, yeah.
This is a situation where you literally sacrifice 3 years of your life. You determine that this is the most important thing in your life, and the things that many other people seem to take for granted, being able to go out with friends, right? Go out to dinner, see movies.
Having friends, that's right.
The 4th of July, I'll be the flight director for the Sol-1, so I'll get to stand there with the mission director, and when we first get the first packet of telemetry back from Mars, we could just see what information we got from the entry, descent, and landing. That's the first data we'll send back, and we'll also send back information about how we're tilted on the surface.
We're landing in a place called Vallis. It's the mouth of a very large outflow channel. This oval is 200 kilometers long by about 100 kilometers across. This is our bullseye. Water had flown across the surface and carved these really enormous teardrop-shaped channels. One of the great things from a geologist's perspective about that is that if you can go and land downstream from those floods, you will go to a place, a delta, where rocks of all types from the highlands to the south will have deposited themselves. And if you're landing on an area like that and you've got yourself a small robotic geologist called the Sojourner, you can learn a lot about the variety of rock types on Mars.
Sojourner will spend at least a week creeping around the vicinity of the landing site. It's unlikely to find evidence of life. That will be the aim of later missions. But it should teach the JPL engineers a lot about remote control.
Controlling rovers on Mars is very challenging. Because of the 40-minute speed of light delay back and forth between Earth and Mars, we can only talk to the vehicle once every so often. And in fact, there's more of a constraint, which is the availability of the huge antennas on Earth that we use to talk to all of our spacecraft. So we send it a whole day's worth of commands, and it has to do then a whole sequence of science activities, and hopefully it doesn't fail somewhere along the way and interrupt its sequence and stop.
The first questions people ask me, well, will it work? Will the hardware break? I'm way past that. We've tested and tested and tested all the pieces, and right now it's out of my hands, and it will work.
Of course we're worried anytime we do these space missions. This is very, very difficult stuff. Mars Observer was a magnificent spacecraft, and it was lost. It disappeared. We don't know why.
The billion-dollar Mars Observer died suddenly just hours before reaching the planet 4 years ago. Perhaps it was a propellant leak. Perhaps it was the great galactic ghoul. The ghoul has certainly been busy consuming Russian spacecraft, the 2 Phobos missions in 1988, and most recently, and tragically, Mars 96.
I went to Moscow soon after this disaster. The general atmosphere in my former institute was like at the funeral.
Despite a string of triumphs at the Moon and Venus, the Russians have been appallingly unlucky at Mars. None of the 14 missions they've sent there has fully succeeded. The future of their planetary program now rests on uncertain international collaboration.
I'm afraid there is a danger that the whole planetary program in Russia would be suspended for an undefined period of time.
American workshops are busy, building spacecraft to follow Pathfinder. Many more are on the drawing board in a program of planetary exploration that is unprecedented in its scale and technical ambition.
In the next few years, we expect every 2 years to send 2 missions to Mars. So between now and 2005, we will be sending 2 in 98, 2 in 01, 2 in 03, and then finally culminating with a sample return mission in 05.
We're going to bring back very small pieces of Mars, something less than a kilogram, but carefully selected by a rover from a lot of different areas on Mars. And that's going to give us our very best chance of understanding Mars, what it's made out of, and whether life ever existed there.
The design of the sample return mission is not yet firm. NASA will probably send rovers first to collect samples. Then an Earth return vehicle will bring the precious cargo home.
The sample return mission is a mission which is very difficult. There's a lot of parts of the sample return mission we don't know how to do yet. We'd know how to do it if we had a huge launch vehicle we could use. The problem is to try to do the mission using a fairly modest-sized launch vehicle on the Earth, because you have to launch something that goes all the way to Mars, lands on Mars, and then you have to have a launch vehicle on Mars that'll bring the sample back to the Earth.
3, 2, 1, ignition. Right away, Houston. Vector good.
Both NASA and the Russians have successfully launched vehicles back to Earth from the surface of the Moon, but on Mars everything weighs twice as much.
Vector, you have good thrust.
In the coming era of Mars exploration, vehicles must be designed to weigh as little as possible. A team at JPL is hard at work challenging conventional thinking about rovers.
We're working on a project to build a rover that is so small that if there's any mass left over at launch time, we can fit in that mass and we can come off that vehicle and then explore in the neighborhood of the vehicle. And we've built a vehicle which we call the nanorover, which is about 0.5 kilogram. It's very small. We hope to make it even smaller in the next couple of years, about half this big. And it has the instruments that we need to do science, and it's also able to self-right, which we thought was important because when we looked at the footpads of most of these landers, just coming off the footpad, we could easily be overturned.
Nano-rovers may be adept at scurrying around the surface, but what about going underground? Following the Martian meteorite discovery, that's where life is thought to be.
Virgil, we're going to need them all. FAB.
Those who grew up with the heroic exploits of the Tracy brothers will be delighted to recognize an old friend from Thunderbirds in NASA's wildest schemes. Yes, the mole may be going to Mars.
We would like to explore under the surface of Mars. The surface rovers are able to look for old rocks and possible fossils, but a vehicle like this that could go under the surface of Mars might look for deep, if it were able to go deep underground, might look for life that still exists if there's liquid water well below the surface. So this vehicle moves through the rock and the soil much like a corkscrew. So in a real mission, the lander would hold this vehicle stable while it feeds itself into the soil, and once that has happened, then it's a free-swimming vehicle, and it has 2 science instruments. One, a camera that looks out through this little window, and another that measures the chemical properties of the soil. We hope to have enough instruments to be able to determine whether there are fossil life or extant life under the surface, and at least to select things so that we might bring them back to the surface as samples.
The Subsurface Explorer is just one of an exotic menagerie of rovers now being created to explore Mars. Many could be seen strutting their stuff at a conference of rover designers held on a Californian beach earlier this year.
And there are so few rocks that are small that are seen in at those 2 landing sites But in fact, this rover, it turns out, can go between the big rocks.
In addition to Brian Wilcox's creations, there were rovers from Europe, Russia and Japan.
Lavочkin Association. It's a big space company which developed all Russian and Soviet lunar and for Venus and the Martian projects.
Amidst all the enthusiasm for robotic exploration, there was also one voice of caution.
Primarily the difference between this Marsicon and the one that you just saw.
Carol Stoker is working on the robotic exploration of Mars at NASA's Ames Research Center. She's an exobiologist, an expert on how to search for life on other worlds.
I think it's going to be extremely difficult to find fossil life on Mars. It's a very tough problem to find it on Earth, and any viewer would know from their own experience that if they just walked out in their backyard, did they find a fossil there? It's not an easy problem.
To test the effectiveness of robot exploration, Carol Stoker has been working with a Russian Marzahod rover to see if it can discover life on Earth.
We're sitting on a rock, and we are sitting.
My program at NASA Ames did a field experiment where we took a science team, actually gave the science team exposure to data from a rover that was placed in a very fossil-rich field site.
And how well did the science team do? Perhaps they overlooked the odd microscopic fossil?
No, they were missing very obvious things. They were missing dinosaur tracks the size of dinner plates. But it's an issue of exactly where do you look. You can be 6 inches to the left of where the fossil is. If you're not looking right at it, you are not going to see it. And that's the problem with the rover. It's only going to look where you tell it to look. Actually, I think that our best chances of finding evidence of life on Mars was to send human crews. There's no question that human crews are going to do a better job than all the robotics technology we can develop in the next 30 years, even if we spend the entire NASA budget on it.
It is looking possible that 50 years after Apollo, a human will set foot on Mars.
Okay, copy that. The blue-gray rock. It's not part of the
It will be necessary for humans to go to Mars because they are us. We are they.
Did you see it, Bob?
And we will insist, we, our human species, will insist on some time scale of our surrogates going there.
Okay, we're headed that way. You get the tongs, John? Yep. I'll carry the rake. Hey, Tony, my guess is that most of these rocks around here are extremely sharp.
The first human mission to Mars could take place as soon as the year 2020. It will be one of the great adventures of the next century. And the people who will make that journey are probably alive today.
In 2020 Vision, I was trying to capture what the first planetary geologists look at a rock on Mars containing life, what that geologist's reaction might be.
Mars calls. I've been trying to go all my life. Given the pace of the current program, I don't think I will personally go. But I think that I will have a vicarious experience of having gone by operating rovers on Mars, even this summer.
I'm going to be on the surface of Mars on the 4th of July in the sense that I'm going to be there watching the data come in. I will be involved in the control of these vehicles. And the fact that I'm not physically there will not be important to me. The fact is that as far as I'm concerned, I will be vicariously there, and I will be doing the exploring just as much as if I was there in person.
Stay
stay tuned to BBC2's Weekend on Mars, which continues. So just a little later than scheduled because of the exciting semi-final at Wimbledon, there's a look at the Martian weather prospects next. And then we join Clive Anderson live on Planet Earth.
Let's go to Mars.
3 men on a mission.
I said there's no time to explain. Please follow me. Now!
Or are they?
It's gotten out of control. What about our families?
The American dream turns sour
Ready, slow-mo. Take slow-mo.
in a fight to the death.
Something's wrong. Something big.
Elliot Gould. Oh, what a day. O.J. Simpson and James Brolin. Capricorn 1, part of A Weekend on Mars, Sunday, 11:20 on BBC2.
It's a comedy of errors for Victor Meldrew on BBC One now. And if you're in Scotland, you can see the Jasper Carrott trial. This is BBC2's Mars Weekend, and we'll be joining Clive Anderson in a couple of minutes after a look at the Martian weather forecast with Ian McCaskill.
Hello, good evening. As if it wasn't hard enough forecasting for Earth, the Martian weather systems are even more chaotic and unpredictable than our own. Mars is much smaller than the Earth, and its gravity only 1/3 as strong. This is not all good news. Throw away your Zimmer frame, because even the lightest of winds can disturb the powdery red surface and cause dust devils or sometimes Mars-wide dust storms, turning the blue sky pink. The weather on Mars, like on Earth, can be very changeable. There are weather fronts there too, but in addition, Mars' orbit is more elliptical than our own, taking it much further away from the Sun for a time during its 687-day long year. Another cause of climatic chaos is the atmosphere itself, comprising of carbon dioxide and just a little water vapor. The carbon dioxide can and does change quickly between solid and gas, causing pronounced pressure changes and thus wind. But no rain. It hasn't rained for a very long time in Mars, several 100 million years of hosepipe ban, in fact. The atmosphere is now far too thin and cold, with what little water vapor there is trapped in ice crystal clouds and frost. You can see the ice caps are here and here, mostly made up of frozen carbon dioxide, or dry ice, as we call it on Earth. Dust storms are the big thing, though. You can see the dust sweeping across the plain, and the sun's heat on the clouds of dust can give the storms an added boost and a life of their very own. Of course, what we're really interested in is the weather at the landing site of NASA's Pathfinder spacecraft. The site, known today as Vallis, is on an ancient floodplain. The weather conditions for this area of Mars are usually fairly quiet at this time of year, with temperatures between -80 and -100 degrees Celsius. At the moment, there's a dust storm churning through the deep canyons of the Valles Manners canyon system, 1,800 miles long and 600 miles south of the landing area. This is a shot of the surface on a fine Martian day. At the site itself, there's a lot of thin, wispy ice crystal cloud at the moment, just like our own cirrus clouds, and this will hopefully keep the surface temperature down and also keep the dust down in the canyons. So a good bet for the weekend that Vallis is very cold and cloudy, but very, very dry. Wind speeds typically 10 miles an hour with gusts to 60 miles an hour. So a chance of some interesting weather then. And look out for those dust devils. That's all from me. I wish you a very good night. Bye-bye for now.